Today we'll have more examples on exponential equations and inequalities. So remember that by one-to-one property for exponential functions, if we have b raised to x equals b raised to y, then their exponents are also equal. Note that in order to use the one-to-one property, the bases must be the same for the left and right side of the equation. And of course, the laws of exponents are needed. For example, we have 16 raised to 2x minus 3 is equal to 4 raised to 2x. So take note that 16 can be written as 4 squared. So we can choose 4 as our base. And then by power to power rule, these 2 here can be multiplied to 2x minus 3. That's why we have here, this is power to power rule. Now from this point, we have now the same base. We have b raised to x equals b raised to y. And the implication is by one-to-one property, the exponents are equal. X is equal to y. So therefore, this 2 times 2x minus 3 is equal to the exponent on the other side, x plus 2. And then we will solve this in the usual manner. So we have distribute 2 to 2x, we have 4x. 2 times 3 is, or 2 times negative 3 is negative 6, which is equal to x plus 2. And then I will transpose x on the other side, so this will become negative x. And negative 6 will become positive 6. 4x minus x is 3x. 6 plus 2 is 8. 3x is equal to 8. And then to get the value of x, we divide both sides by 3. So we can cancel 3. So therefore, x is equal to 8 over 3. Example 2, we have 1 half raised to 2x is equal to 2 raised to 3 minus x. So take note that when we take the reciprocal of this, the exponent will change, or the sign of the exponent will change. Okay, so take note, we have this. 1 half is equal to 1 raised over 2 raised to 1. And then by applying the law of exponents, this will become, if we take the reciprocal, this will become 2 raised to negative 1 over 1, or simply 2 raised to negative 1. Okay, and take note here in our problem, we still have 2x. So meaning here we also have 2x. And here we also have 2x. By power to power rule, we have 2 raised to negative 1 times 2x. We have negative 2x. That is why we have this negative 2x. Okay, and now we have the same base, 2. So by one-to-one property, their exponents are equal. Negative 2x is equal to 3 minus x. So I will transpose this 2x on the other side so that it will become positive. So 2x minus x, and 3 will be negative 3 transposed to the other side. So 2x minus x is x, and therefore x is equal to negative 3. Example 3. So it's still, we have another fraction. So this is the given. So we can rewrite 27 as 3 cubed. 3 times 3 is 9 times 3 is 27. And 9 can be written as 3 squared. Again, from our previous discussion, if we take the reciprocal of this will become 3 raised to negative 3. The exponent of 3 here is this 3. So if we take the reciprocal, the sign will change. And then we still have 4 minus x. Then on the right hand side, we have the power to power rule, 2 times 2x. So we have it here. Next, on the left side, we have again the power to power rule. We will multiply negative 3 to the quantity 4 minus x. and then 2 times 2x is 4x. So by one-to-one property, the exponents are equal. Negative 3 times the quantity 4 minus x is equal to 4x. Now distribute. We have negative 12 and positive 3x. Negative times negative is positive 3x. Again equals 4x. And then I'll transpose 3x. So it will become negative 3x. So 4x minus 3x, we have x. So x is equal to negative 12. Next example, we have here 3/5 raised to x and 5/3 raised to 3. Now if you notice, if we reciprocate just one of them, then we can have the same base. So say for example, we choose 3 over 5 as our base. So if we take the reciprocal of 5 over 3, okay, this will become negative 3 because exponents here are 1 and 1. Okay, 1 and 1 lang man. So if we take the reciprocal, we have negative 1. So times 3, we have negative 3. So 5 raised to 1, 3 raised to 1. If we take the reciprocal, 3 raised to negative 1, 5 raised to negative 1. Okay? And then, by the law of exponents, this is 3 raised to negative 1. Okay? And take note, we still have 3. So, negative 1 times 3, we have negative 3. So, I just used the word reciprocal because we interchange the numerator and denominator. Okay, because students also use that term when they do the interchanging of the numerator and denominator. Okay, so we have here, so therefore x is equal to negative 3 because of one-to-one property. No, both of them have now 3 over 5. Now what if we choose 5 over 3 on this side? So this side will be negative x because this one will be reciprocated. Okay, so negative x. So by one-to-one property, they have now the same bases, 5 over 3. So we have negative x is equal to 3. And we can multiply both sides by negative 1 to eliminate the negative sign for negative x. We have x is equal to negative 3. So we have the same answer. Last example for equation. We have 1 over 8 raised to negative x and 1 over 32 raised to 1 minus x. So 1 over 8 can be written as 1 over 2 cubed because 8 is 2 raised to 3. 32 is 2 raised to 5. Then we take the property. Take note that 1 can be written as 1 cubed or 1 5. Okay, so we can use the property if we have a raised to m, b raised to m. This is equal to a over b raised to m. So that is why on the next line 3 or the exponent 3 is factored out. So we have now 3 like this. And also on the other side we have 5. Okay, so we have now the base 1/2. Okay, so the exponent is or are equal. The exponents are equal. So 3 times negative x is equal to 5 times 1 minus x. So we have negative 3x is equal to 5 minus 5x. I will transpose positive 5x, negative 5x, so it will become positive 5x. So 5x minus 3x is 2x. And dividing both sides by 2, this is 2. X is equal to 5 over 2. Okay, now let's go to exponential inequalities. So we have two cases here. If our base is greater than 0 or greater than 1, no, this is not 0. If the base is greater than 1, then we have this result. If we have b raised to x is greater than b raised to y, if and only if x is greater than or equal to x is greater than y. This means that the relationship of the two exponents follows the original inequality, meaning if the relationship here, inequality here, is greater than, less than, less than or equal, greater than or equal, the relationship of the exponents also follows that direction. So the exponents, on the exponents sides, we have greater than, this is also less than or equal, greater than or equal. Okay, if base is greater than 1. Now, if it's between 0 and 1, then we have this. It means that the relationship of the exponents take the opposite direction of the original inequality. Say, for example, if you have greater than from the original inequality, on the exponent part, the relationship of the exponents is less than. If it's greater than or equal, on the exponent, it's less than or equal. If it's less than, it's greater than. If it's less than or equal, it's greater than or equal. Okay, so that is if the base is between 0 to 1. Again, if base is greater than 1, it follows the relationship, no? The exponents follows the original inequality. But if it's between 0 and 1, it does not follow the original direction of the inequality, but it takes the opposite direction. Okay, so the same thing, the bases must be equal, must be the same so that we can use this property, and the laws of exponents are still needed. And of course, take note, this is inequality, so the answer should be in interval form. So example, 4 raised to 2x plus 7 is less than or equal to 32 raised to 2x minus 3. So we have this. 4 can be written as 2 squared. By the way, we cannot use 4 as our base because we cannot express 32 as base 4 with integer exponent. Okay, so we will choose 2. So 4 is 2 squared, 32 is 2 raised to 5. And then by power to power rule, the exponents here will be multiplied also on the other side. Now, since our base is equal to 2, which is greater than 1, the direction of the exponents follows the direction of the original inequality. So if it's less than or equal, so the relationship of the exponents is also less than or equal. Okay, so we have here distribute 4x plus 14, we have 10x minus 15, and transpose 4x, so we have negative 4x, this 15, transpose on the other side, positive 15. So we have 29 is less than or equal to 6x. Dividing both sides by 6, we have 29 over 6 is less than or equal to x. So in interval form, if we look at the number line, so we have the negative infinity, positive infinity, and we have the 29 over 6. Okay, 29 over 6. So 29 over 6 is less than or equal to x. So meaning the x's are here. Okay, because because 29 over 6 is less than to all values of x. So meaning our interval is from 29 over 6 bracket, because we're using less than or equal, so bracket, to positive infinity. Okay, so meaning we have this final answer. So it's either this one or this one, interval in form. Next, we have this. So just like in equation part, we have an example similar as this. So we can just take the reciprocal of any of these two if you want. So say for example, we choose the base as equal to 2 over 3. So if it's 2 over 3, so this is as is. So this side will be negative 2x because of the reciprocation, or if we take the reciprocal. Okay, so 2/3. Now 2/3 is less than 1. So meaning the direction of the inequal or the exponent is different, or it takes the opposite direction. So since this is less than, the direction for the uh, exponents is greater than. Again, since the base is less than 1. Okay, so that is why we have greater than. Okay, we transpose negative 2x, so it will become positive 2x. This 2 will become negative 2. We have 7x is greater than negative 2. Dividing both sides by 7, we have x is greater than negative 2 over 7. So we have this. Since this is only greater than, we will use the parenthesis. So if we have negative 2 over 7 here, meaning x is greater than. So again, it's on the right side. The x's are here because x is greater than negative 2 over 7. So the x can take any values on here, on this side. So meaning it takes, or it runs through negative 2 over 7 to positive infinity. Okay, now if we take the base as equal to 3 over 2. So if 3 over 2, then again, this is as is, and this one will be reciprocated. So this will become negative, the quantity of 5x plus 2. Then now, since the base is greater than 1, so we will follow the original relationship, so less than. So this is also less than. Okay, so if we distribute the negative 1 or the negative sign, we have negative 5x minus 2 is less than 2x. So I will transpose negative 5x on the other side. We have 5x plus 2x. And then we have this, 5 plus 2 is 7. Then dividing both sides by 7. So here it means that negative 2 over 7 is less than x. So the same thing, because it also means that x is greater than negative 2 over 7. So the same answer. So you choose whether your base is greater than 1 or less than 1. Either case, the result is still the same. Last example, if we have this. Now take note, we can rewrite 25 as 5 squared and 4 as 2 squared. And by the property of law, or by law of exponents, we can rewrite it this way. Now from here, you choose whether you want 2 over 5 or 5 over 2. Now let's try first 2 over 5. So this will become negative 2, kaya nag-reciprocal. And then, since the same ng base, then we have this. Since the base is less than 1, 2 over 5 is less than 1, the direction will change. So this is greater than 1, so the direction here is less than or equal to. And then, transpose, negative 1 will become positive 1. So 5x is less than or equal to negative 1. So divide both sides by 5. So we have x is greater than, no, this is less than or equal to negative 1 over 5. So x is less than or equal to negative 1 over 5. So it means that the x is on the left side. Okay, it's on the left side of negative 1/5 because it's less than. So that is negative infinity to negative 1 over 5. Okay, it's bracket because we're using less than or equal. Okay, let's compare this one. If we use 5 over 2, so if it's 5 over 2, so this is positive, so this is positive, correction. This one will be negative on the other side, okay, because this one is reciprocated. So this is negative, so this is positive, okay. So we have here, distribute the negative 5, so we add the negative 1, so negative 5x plus 1 is greater than or equal to 2. By the way, it's greater than or equal because it's greater than 1. The direction still remains. Now it follows the original inequality. So transpose negative 5x, it will become 5x. 1 minus 2 is negative 1. So dividing both sides by 5. So negative 1 over 5 is greater than or equal to x. So therefore, we still have the same answer. Okay, so if you want to practice, you may solve this equation from the first part. Okay, and you just change the equation part, the equation symbol to inequalities. Because the process is still the same, they only differ on the one-to-one property. So this one, say for example this one, you may change this one as less than or greater than and so on. The steps is still the same, but be careful on this part because the one-to-one property is not the same. And another set of examples only on exponential equations. So remember that if b raised to x equals b raised to y, then x is equal to y. So again, the bases must be the same for the left and right side of the equation in order for us to apply this property. And of course, the laws of exponents are needed. So example, we have this. So we have 4 times 2 raised to x plus 1 is equal to 1 over 8 raised to 2x minus 3. So obviously, our base should be 2. This is the smallest number here. And others can be written as as an expression of 2 raised to something. So 4 can be written as 2 squared. So we have this, and okay, so this is 2 already, so just copy. And 1 over 8, 8 can be written as 2 cubed. Okay, on this side, since this is product, so we can just add the exponent. Take note, if we have am plus b times, sorry, am times b m, no, an, so the same base, this is equal to a raised to m plus n. Okay, so that is why we have 2 plus x plus 1. Okay, and this one, if we take this with the laws of exponents, or other students say reciprocal, so we have 2 raised to negative 3. Okay, and then by by the one-to-one property, we have now this, the base is 2. So we have the exponent here on the left hand side, 2 plus x plus 1, we have this. And on the right hand side, by the power to power rule, we have negative 3 times 2x minus 3. Then we have 2 plus 1 is 3, and distribute this. Negative 3 times 2x is negative 6x. Negative 3 times negative 3 is positive 9. So transpose, negative 6x will become positive 6x. Then negative 3 will become positive 3 will become negative 3. So we have 7x is equal to 6. And dividing both sides by 7, we have x is equal to 6 over 7. Next example, we have this. So we have 27 times 27 raised to 2x minus 3 is equal to 81 raised to 3x minus 5. So obviously, we cannot rewrite all of this in terms of 27. Also, in terms of 9, it can't be, because 27 can't be an exponential form with base 9. So we choose 3. So 27 is 3 cubed. So we have this. And 81 is 3 raised to 4. Again, by the law of exponents, since this is multiplication, we can just add the exponent. So we have, okay, for this one, we have the power to power rule. This is power to power rule, and this one, we add the exponents. Okay, add exponents. And on the right hand side, we have power to power rule, and then distribute 4 times 3x, we have 12x. 4 times negative 5, we have negative 20. So we have now the same base. So the exponents are equal. So we have 3 plus 3 times the quantity 2x minus 3 is equal to 12x minus 20. So distribute 3, we have 6x minus 9. And then transpose, I'll transpose 6x here. So we have 12x minus 6x, and negative 20 will become positive 20. So we have 14 is equal to 6x, and dividing both sides by 6, x is equal to 14 over 6. Next example, if we have this, so we can use again, there's a 2. All of these, 16, 32, and 128 can be in exponential in form using base 2. So we have 16 is 2 raised to 4, 32 is 2 raised to 5, and 128 is 2 raised to 7. Okay, by power to power rule, we have this. 4 times the quantity x minus 1. On the denominator, we have 5 times the quantity 2 minus 3x. Then we have this. Since this is multiplication, so we will add the two exponents. So 4 times the quantity x minus 1 plus 5x plus 2. On the denominator, I just distributed 5, so we have 10 minus 15x. And just copy the right-hand side. Now take note, for the next slide, take note, recall that if we have a raised to n, now this time divide by a raised to m, it is equal to a raised to n minus m minus. If it's division, it's minus. If it's product, it's plus. Take note, if it's product, a raised to n times a raised to m, it's equal to a raised to n plus m. But if it's division, it's subtraction. So that is why here we have subtraction. Okay, the numerator, exponents on the numerator minus the exponent of the denominator. Okay, so we can simplify this. We have distribute 4. We have 4x minus 4. Just copy plus 5x minus 2. And this on this part, we have negative 10. Negative times negative, positive 15x. Then combining like terms, we have 4x plus 5x equals 9x. And plus 15x, we have 24x. Then we have negative 4 plus 2 is negative 2 minus 10, it's negative 12. So now, applying the one-to-one property, we have 24x minus 12 is equal to 7. So transpose, we have 7 plus 12, and then dividing both sides by 24. So we have 19 over, 24 over, okay, it's wrong. It's 19 over 24, sorry. So this is 19 over 24. Last example. So what if we have this? So our base here is 3. So 27 can be written as 3 cubed, 9, 3 squared, 81, 3, 4, and 243 is 3 raised to 5. So by power to power rule, we have this 3 times negative 3x. On this part, since I'll take the reciprocal or applying the law of exponents, this will become 3 raised to negative 2. And power to power rule, we have 4 times 2 on the denominator. And on the right hand side, this will become 3 raised to negative 5. So we have this 3 times negative 3x is negative 9x. And by the power to power rule, we have this, multiply the two exponents. And on the denominator, 4 times 2 is 8. And just copy the right hand side. Next is apply the other laws of exponents. So this is multiplication. So meaning the negative 9x is added to the negative 2 times 2x minus 1. So it's plus. But since this is negative, positive times negative is negative. So I'll just use directly the negative symbol. And then since this is on the denominator 8, so this will become negative 8. Now I use the a n over am. So this is 8 on this side, so that will become negative 8. Now a raised to n minus m. So simplify, negative 2 times 2x, we have negative 4x. Negative 2 times negative 1 is positive 2. So by By this, negative 9x minus 4x. So combining like terms, we have negative 13x. 2 minus 8 is negative 6. So now we can have the one-to-one property. We have negative 13x minus 6 is equal to negative 5. So we have this transpose negative 6. So we have 1. So dividing both sides by negative 13, we have x is equal to negative 1 over 13. So in general, in order for you to solve this type of exponential equations or maybe inequalities, again, you can just change the symbol from equal to inequality and apply the rule based on our previous video. Now all you need to do is to be familiar with the laws of exponents. Okay, the laws of exponents and some basic properties of algebra. So thank you for listening.